Bismillahirrahmanirrahim. In this video we learn about inverse Laplace transform with two examples from Mr. Irwin's book. Now let's recall the procedure for a Laplace transform. First we transform the problem from time domain to complex domain or S domain while doing Laplace transform. And then we solve the circuit in time domain. And then, we solve the circuit in complex frequency domain. And then we revert back to time domain. Now this process of reverting back into time domain is the inverse Laplace transform that we'll talk here. Now the steps that we got to follow is we got to decompose into simple terms. So like this is the example, so we decompose it by partial fraction, and then for each term we take the inverse Laplace transform from the table given in the book. Okay, so let's solve the assessment problem number 13.8. This is the question given. This is in Laplace domain of frequency domain or complex domain. We have to find the value in time domain. So as we mentioned, we got to break it into with the help of a partial fraction. So these three factors, we separate them and we assume that we have a numerator k0 for s, k1 for s plus 1 and k2 for s plus 4. And now we got to find the values of k0, k1 and k2. So I prefer residue method, and in that we multiply by the denominator of whichever variable we want to find. So we want to find k here, so we multiply the whole thing by s. So we multiply by s fs, that is this term. So ss gets cancelled, so this is the term remaining. And then we apply this condition that s is equal to 0, so we put s is equal to 0, and in this if you put s is equal to 0, this becomes 0, this becomes 0, so 1 at the top, and here this is 0, so 1 multiplied by 4, so 1 by 4 and is equal to 0.25. So this is the value of k0, and similarly k1 we multiply by the denominator of k1, so s1 multiply by this, and the condition now will be s plus 1 should be equal to 0. So s plus 1 equal to 0 means s is equal to minus 1. So we put that condition. Now when you multiplying by s at the top, so this s1, s plus 1 and s plus 1 get cancelled. So this is what is remaining, putting value of s is equal to minus 1 in this, so this will become plus 1, this will become minus 5, plus 1, so 1 and 1, 2, and minus 5, so it will be minus 3 at the top, and here it will be minus 1, multiplied by minus 1 plus 4, that means 3, minus 1, so minus 3, so the answer is 1. And similarly, for k2, we multiply by the denominator of k2, that is s by 4, so s by 4 gets cancelled from here, so this is the remaining term, and the condition now is s is equal to minus 4 from here, s plus 4 is equal to 0, so s is equal to minus 4, and so putting in that value we get this value to be minus 0.25, and now we take help of this formula. So let's plug in the values here first of all. So this is the values of fs, and now we'll use this formula. We're going to go to in the reverse direction. We have the s domain given, we got to find the time domain. So 1 over s will be ut, and 1 over s plus a will be e raised to the power minus at. So using this formula, ft will be Laplace inverse of this, so Laplace inverse of this, Laplace inverse of this, and Laplace inverse of this. And so Now from here you have 0.25, 1 over s is ut. From here 1 over s plus 1 will become e raised to the power minus at will become minus 1t ut, and from here 0.25 e raised to the power minus 40 ut. And so the final answer given in the book is like what we got here. Now let's go to the assessment problem number 13.9. Now this is slightly difficult from the other ones, so let's see. This is the problem. Now we have to factorize this. So we can write it as s square 2ab, so 2s into 2. That means we need a 2 square here. 2 square is equal to 4. So out of 8 we have taken 4, so 4 remains here. So 2 square. And so this can be written as s plus 2 whole square minus j2 whole square. You know that j square is minus 1, so minus minus will become plus. So that is why you are writing in this form. You have to actually use the formula a square minus b square. That is why we are making this manipulation. And now by a square minus b square formula, a plus b and a minus b. So these are the two factors that we got. And now we assume that the numerator for the first term is k0 and the second term is k1. And as we did in the previous example, we will just follow the same procedure. k0 is the denominator multiplied by fs, and condition here is that we put this equal to 0. That means s is equal to minus 2 plus j2 from here. So this is the condition. And now when we multiply by this, then we have this term remaining. So it is s divided by s plus 2 minus j2 this term. And we put the condition s is equal to this. Plugging in the values, and this we get as shown here. I hope you can do this. And simplifying, we get minus 2 minus j2, and here 2 gets cancelled, so we will get minus j4 or 4j. And this in polar form can be written as shown here. Simplifying, we get 0.707 angle minus 45 degree. So this is the value of k0. Similarly, we find k1, we multiply by the denominator of k1, put the condition from here s is equal to this value, and same way that we did here, plugging in the value, we are getting 0.707 angle 45 degrees. So it is plus 45, here it was minus 45. So we got the two values. And so we can write that fs from here, we're putting in the value of k0 and k1. So this is fs. Okay, so we are here. Now let's proceed. Our aim is that we should get a denominator like this. So we can use this formula. Okay, we take the common this term. So we have 1 divided by this term and 1 angle 90 divided by the denominator. And you know 1 angle 90 is actually can be written as j. J is equal to 1 angle 90. Other things remain same. And from here we take the LCM of the two. 1 multiplied by this one and j multiplied by this term. Simplifying, and this multiply will give you this term. And so Further simplifying, we get s plus js and divided by the s2 square plus 2 square, j square will be minus 1 multiplied by minus will become plus, so plus 2 square. And we take s common from here. Now 1 plus j polar form will become 1.414 angle 45. We multiply this term with this and the angles will be added. So we get S, because 1.41 multiplied by 0.7 is approximately equal to 1, and 45 plus and minus 45 added will give you 0. So only S remains, denominator remains same. Okay, so we were here and now we'll manipulate it further. We split it or write it like this: s plus 2 minus 2, so plus minus will cancel, so virtually it is s. But why we want to write it in this form is because we want something like this, matching something like this, so s plus 2 and minus 2. And now we can separate these terms. So s plus 2 divided by the denominator minus 2 divided by the denominator, and now we can see the benefit that this is matching this equation and the second term is matching this equation. So now we can plug in the values. So if you take the inverse of this and inverse of the second term, so we get e minus 2t cos 2t ut from here, and for this case from here we get e minus 2t sin 2t ut. So this is fine. If you write up to this, your answer is correct. But since in the book he has manipulated it further, so we'll also, for your information, I'll do that. Okay, so from here we're taking ut common. And now we'll use this formula: a cos omega t plus b sin omega t is equal to c cos omega t minus theta, where c is a square plus b square and theta is tan inverse beta over alpha. So we'll take this part and manipulate according to this formula. So cos 2t minus sin 2t, we can write it as 1 into cos 2t plus minus 1 sin 2t. So it just matches this formula now. And so c is equal to under root a square, our a is 1, plus b square, our b is minus 1. So from here we get c is equal to 1.414, and theta is b over a, b is minus 1, a is 1. So tan inverse 1 is tan inverse minus 1 is minus 45 degree. So this can be replaced by this value c and cos omega t plus 45, because this is cos omega t minus theta, our theta is minus, so minus minus plus, so 45 degrees. And now we plug this in here. So e minus 2t, for this we got 1.414 cos 2t angle 45 multiplied by ut, and this is the answer given in the book. He has written 1.41 e minus 2t this. So this is the pattern given as per the book. So I hope this gives you an understanding how to solve this type of problem. Thank you.